Good morning and welcome. I'm showing you a photo, and in the meantime I would like you to think of applications in which you have participated or you had to help develop, and you probably had to use a web service or use something did by another person, or maybe with Genexus you had to use an internal object, to use a component made by someone else. Maybe you had to integrate with something already existing, or you went to the cloud and use the services there. Because the applications, the modern ones, don't run by themselves, they don't live by themselves, they are integrated to others, or they consume data from other sources. So this is what I'm going to talk about. I'm going to talk about the new players that have appeared in this new way of integrated or consuming other things, how they have evolved with more flexible ways of conversation to communicate, or if we go to the cloud and use services in the cloud. Let's take Uber as an example of a modern application. Uber is not only in the cloud, it uses cloud services, but it's also an application that was built on the basis of APIs. Without the connection with Twilio, the company would not have existed. They centered on their basic, on their core qualifications, and once they reached the big public, they opened with their own API, allowing our developers to build on top of that. That is why there are many applications like this, Foursquare, that is integrated, and it's an application of things to do. And in its screen there is an access that says travel with Uber, and it connects with Uber's API. So any application that has a map is potentially a consumer of Google's API. Alexa is another example that also consumes Google API. And with this, Uber managed to reach a public that maybe they wouldn't have been able to reach in another way, like Foursquare users, and also to create new business models for each use of their API. This would be the scenario of a modern application, what I'm going to describe today, where there are new players and the scene has evolved. Players go to the cloud and they expose and consume APIs. To look at these new players and tell you what Genexus did about them, let's assume that we build a modern application and we're going to put it in the cloud. Assume that it's a system to sell insurance. So I'm going to put it in the cloud first, Amazon's cloud, because we want to go to this platform and the cloud. And here we find the first player. This is the blog of the novelties of the .NET platform, and you see here the new features that are released for .NET Core, like Lambda, etc. And these are summary of what happens in general and not only in Amazon's cloud. What happens in general is that the evolution of Amazon's .NET is .NET Core, which is a lighter version. The previous one came from Windows, and this one, .NET Core, is modularized, so the application is going to install only what is needed. It can have its framework version, and it has a substantial improvement in its performance, since Microsoft made it from scratch without having to face compatibility of the past, so it has a much better performance. It's cross-platform, So it doesn't run only in Windows but also in Linux, and this positions it as an alternative to Java, for example, when it's about going to the cloud, because now it competes with the Katu prices. It is maintained by Microsoft and by the net community of GitHub, and that is why it has a good performance. If we compare framework with .NET Core, we will see that framework has released less versions and more space than .NET Core. The features that appear in .NET Core go later to framework. So this is the first player in the scenarios of modern applications I wanted to describe. Now let's say that we put the application on the cloud. We are with .NET Core, and this example we're having sale of insurances. We want to personalize it. We would like to give our clients a personalized treatment. When a client comes, I should be able to know him, know his profiles, whether he travels or not, whether he's adventurous, in order to offer more adequate features. It would be interesting to know this. And for this, it would be useful to consume the API of Personality Insights of IBM, which is based on artificial intelligence. For example, on the basis of what a person publishes in the social networks, it can estimate the personality of the person in question, and this would be very useful in order to offer these potential clients something adapted to his or her needs. And I took this example from a marathon champion who publishes a lot in the social networks, and this is an analysis of his personality that shows many features of his personality. He's explosive, he's active and helpful, and all this is calculated on the basis of his publications in social networks. He likes busy schedules, he's a volunteer for social causes, and maybe we could offer him quite a complete insurance policy. But in order to consume an API like this one, or any Watson API, or many of the APIs out there, we had to use the Open API protocol. It was created some time ago as a replacement of SO, which is the one we were used to consuming. This is more modern than the SOAP version, and it's simple. It's an HTTP service that receives data, for example, the publications that the user did in the networks, and then it has outgoing data. It establishes the profile in the URL because it's the logic that calculates the profile, and the data structures are fixed, are known. They are defined in a metadata, and so this is how it operates, with data coming in and going out. So that's the second player, which is being adopted by APIs in general. In order to use it, I had to understand OpenAPI and talk to it. So now we have a personalized system in the cloud, and I would like to integrate it with my Outlook. We needed to interact with my mail, my calendar, etc. And it is useful, therefore, to consume an Office Outlook, which brings me my email, my mail, my calendar, my contacts, etc. And it does it through another protocol, which is OData. OData is a protocol that was invented by Microsoft several years ago and became fashionable again when SAP took it as a way of exposing its entities. SAP can be extended through Business One to Business One through OData. But OData does not expose specific services, but a series of entities and its relations, like a database. At a higher level, it exposes entities with their business rules, etc. So what comes in is a query, sort of SQL, and if I want to read the mails that have not been read and I want to order them by according to the importance of the sender, I send a query like this one and I get a structure according to the query I made. So it's another way of communicating, of talking, much more flexible, because here it's the consumer who defines which query he wants to send. This one extracts data, but there may be queries that modify, that insert, etc. So this is the third player that we are going to find when we consume APIs. So what did we do in GenXus about this? We added a new generator and we released a first version in GenXus 16. This is a new generation, but it shares some of the experience that we had with the .NET generator. The wikis page, which is public, which you can see, has been created with this generator. The current state of GenXus 16 is summarized in this slide. It supports the development cycle of an application based in the cloud, so it supports external storage deployed to cloud, but we need to support some BMS. But gradually, they are going to be incorporated in the coming upgrades. The geographical data, for example, are also missing. This is what we did for GenXus 16. OpenAPI, we have an inspector, and when we want to consume something that has been exposed in OpenAPI, I give you the example of the people. Well, we have an inspector that, when the metadata are imported, creates a series of procedures and SDTs which encapsulate the calls to this service. For the case of the profile of IBM Watson, it created the profile API and a series of SDTs that represents what comes in and goes out of the API and simplifies the interaction. Also, the rules will include the parameters that are required in the tokens for the authentication, which I omitted from the example. If we want to build the other leg, that is to say, expose my services and the data protocol, and I want to expose my API, I can also do it. This is a property at the level of GenXus objects that are exposed in the business components, data providers, and procedures. The property comes from here and creates the OpenAPI interface. Now, it's not as easy as saying as put it or not. There are many topics related with it, like security. If the objects have a GAM, the security of the GAM will also apply, of course, to the interface or data. But there are other tools that can be interesting, like these two, Amazon API and Google Cloud Endpoints, which operate as a proxy of the APIs I expose and create a layer where I can define security and do the monitoring and the tracing and many things around the APIs, like access control. That is to say, a lot of tools that can be useful. So far, we've seen what we did in GeneXus, but I miss saying this. If we want to generate for the first tool, the Amazon tool, since there are some additional restrictions with regard to the names that are published and some syntaxis details, we have a property to indicate this so that the metadata generated are compatible with what Amazon states. And what did we do for our data? The other protocol, you remember, the one we use when we consume the office. We also have an importer. Remember that this protocol was somewhat different because it's oriented to entities. This importer takes metadata from the OData services that defines the entities and their relations, and it creates in GeneXus a series of transactions that represent the entities. So GeneXus resolves the correspondence between the entities that are exposed with the data and the relational tables. It does the correspondence between the entity model and the relational model. So here I can program as I'm used to doing. If I have a transaction, I can program it for each like this one, and when it's executed, GeneXus is going to translate it to the consultation format expected by OData, as you see. In OData, we can also expose. It's not in GeneXus 16, but it can be tried in GeneXus Beta, which is in the beta channel. There you can try expose business component and data provider with OData. This is what we did in GeneXus for these new players, but things don't end there. There's more to do. There's a new player which is GraphQL. It's a protocol introduced by Facebook, which is gaining ground, and it's an improved version of OData. It has the same concept of entities and relations between them, all of the entities that are connected, and establish a graph. And it's basically this. This is a GraphQL service that gets me a geographical location. And the interesting thing is that the query of the OData is specified here according to the entry structure, and it's isomorphic. The structure is the same incoming and outgoing, but it has the data when it goes out. So the consumer specifies which are the fields that he wants to read. So I will have a response that is adequate to the demand of information. Therefore, it's very flexible for consumers. This same service, this same URL could receive another entry information. I ask besides the country, the continent, the geographical location, and the same service will provide additional information. The main advantage is that the consumer does not need to do n round trips to the server to get the information. He can ask the information just one and gets all the information about the entities he needs. And it also avoids overfetching. The APIs have the problem that when they evolve and when you add or delete fields, it's a problem to keep compatibility with what has already been done. But since it's a consumer that specifies what he wants to read, if fields were added, the user doesn't even find out. This is another service. It's an extractor of text of web pages, and it shows that the queries, the structures that can be sent are very powerful. You can obtain relations between entities and serve and do very powerful things. I can have all the text of an HTML page or all of the links or certain hierarchies of the HTML elements, etc. So these are the main players I wanted to describe. And to sum up, the new players, we have .NET Core, which is a Java alternative when we talk about services in the cloud. But if we don't want it in the cloud, it improves performance anyway vis-a-vis the previous services. We have a new way of consuming and posing APIs, but mostly my message is that the important thing is not how I expose or how I consume. The important thing is that we look at the possibilities around us, we look at our competitors, because it's very likely that they will have an API that will be useful for us to consume, or that we have to expose an API that will make our reach a different public or have a new business model. So we should look around us. Our competitors may be our followers too, and it was the case as was the case with Uber. The rest can be solved simply with GenXus. Thank you very much.